are the frequently asked questions for pre-calculus, and this is for section 5-6, day 2. And the first one that was asked for was number 36, designing a baseball field. Find the distance from the center of the front edge of the pitcher's rubber to the far corner of second base. How does this distance compare with the distance from the pitcher's rubber to first base? Well, there's two ways to go after this one, and the first one is to say there are certain things that we can assume about this baseball diamond. If you don't know about a baseball diamond, then you're going to have to do a lot more work to do this problem. Because what we know is that this will absolutely be a 45-45-90 triangle. We're guaranteed that, and that's because this is a rhombus, and in a rhombus all of the bases that they're running are spaced equally as they go around. It wouldn't make much sense to have somebody have to run farther from first to second base than they do from second to third base, or vice versa. So if that is the case, then this, being a 45-45-90, would be 90 square roots of 2, because to go from side length to the hypotenuse in a 45-45-90, what you need to do is multiply by the square root of 2. So we could take 90 square roots of 2 and subtract 60.5, and we can get the distance that they want us to look at. So let me go ahead and get that up here, 90 square roots of 2. And we want to subtract. And we have about 66.779. And they ask us to compare that to the 60.5 that we have here. Well, it's a little farther. And this was in feet. So it's a little farther when you answer the question, how does this distance compare with the distance from the pitcher's rubber to first base? And then B says, figure out what the measure of angle B is in triangle ABC. So we are looking for this angle right here. And I look at the information and see I have side angle side, which means we should be able to work our way towards the law of cosines for this one. So we are looking for what would amount to the angle B, and I hate to just leave it B because the thing I'm thinking about is there's two triangles taking place here, but in triangle ABC that really is B, so we could just leave that. And we would need to use B squared equals A squared plus C squared minus 2AC cosine of angle B. All right, let me get this formula solved for that cosine of B piece there. I want to make sure at the end that I'm taking the inverse cosine of B squared minus A squared minus C squared all over -2 times A times C to get the measure of angle B. So now let's go put some numbers in here and see what happens. Our B value was 90. And our A value was 60.5. And our C value comes from the math that we did for the example in class. So you can go back and look at your notes for that one. All right, and then we would need to punch all of that mess right there into the calculator. So let's see what we get. I'm going to do it in pieces. I never like punching all of this in at one time. So 90 squared minus 60.5 squared minus 63.717 squared. And I need to divide that by, and we have -2 times 60.5 times 63.717. And we need the inverse cosine. And there it is, 92.824. degrees. So there's the second part of this, which was just using the law of cosines because we saw a side angle side relationship up there. Next up on your list, we have number 40, which is just a very strange little problem here. It says, two airplanes flying together in formation take off in different directions. One flies due east at 350 miles per hour. And the other flies east-northeast at 380 miles per hour. Now, that's something you may have to look up. What does east-northeast mean? Well, if we had perfect northeast, it would be right here. But halfway between perfect east and perfect northeast is east-northeast. So originally, the green angle that I had there was 45 degrees, because that would have been that perfect diagonal through there. But now, this little angle would be cut in half. So that would be 22.5 degrees. So far, we have this, and it says that one's going 380 miles per hour. How far apart are the two planes 2 hours after they separate? So we're going to need 380 times 2 and 350 times 2 to mark that distance. And 380 times 2 is 760. And they want to know this, and I'm just going to label that C. Now we definitely see that, and it says assuming that they fly at the same altitude, and that would be wind speed and all that good stuff, air resistance. They don't want to make that different. So now what we'd have to do is law of cosines, because we have a side angle side relationship. So C squared equals A squared plus B squared minus 2AB cosine of C. So we will have 700 C squared equals 760 squared plus 700 squared minus 2 times 700 times 760. It doesn't matter which order you put those in. Multiplication is commutative, but I guess I'll kind of stick with what I had up there. And then we need the cosine of 22.5 degrees. And because it very well may be that you had all of that math right, but then you went ahead and punched it in wrong, I will go ahead and punch this in. We've got 760 squared plus 700 squared minus parentheses, because everything after this needs to be subtracted, 2 times 700 times 760 times the cosine of 22.5 degrees. Now that's C squared, so I need the square root of that. Second, square root, second, answer, edit. And that is 290.847 miles. So it is 290.847 miles away from the other airplane at the end there. Then you had one more, and that was number 43, and this is it's kind of a whopper. Got to use the Pythagorean theorem several times here. Angle CAB is inscribed in a rectangular box whose sides are 1, 2, and 3 feet long as shown. So now, I want to find the measure of angle CAB. The problem is, I don't have the measurements for the lengths of the sides just yet. I have to find those. So I noticed that from the bottom parallelogram, I can figure out the length of AB. And that's going to be by using the fact that if this is a rectangular box, I have a 90-degree angle down here, and I would use the Pythagorean theorem. So 2 squared plus 3 squared equals the blue that I want squared. I'll just call that C. 4 and 9 are 13. So the square root of 13 will give me that value. And I notice that that's AB over here on the triangle that I'm already using. And then what I have to do is figure out the other two sides. So now I go to the back panel with A and C, and I need this distance. So I take a look at the numbers and I see this is 1 foot and this is 3 feet. This is going to be 1 foot, this is going to be 3 feet, so I can go ahead and use the Pythagorean theorem again. 1 squared plus 3 squared equals c squared. That's going to be 10 for c squared, so the square root of 10 equals c. So for AC back here, I have the square root of 10. One more time. Now they didn't write the blue line in, but we absolutely need to do that to get a feeling for where we're going to get that information from. So the one last piece that we need, I panel over here, because that last piece of information, remember, is right here. So what I want to pay attention to is the fact that this is going to be a 2 and this is going to be a 1. And then we can use the Pythagorean theorem again. So 1 squared plus 2 squared equals c squared. That's going to give me 5. The square root of 5 is what we're going to get for the last side. So now, we just need to set this up correctly, because if we want this angle right here, we need to obviously have the cosine of A in our formula. And that means we're going to have A squared equals B squared plus C squared minus 2BC, cosine of A, and A squared, oh, I don't want to move that quite so far up, I want you to be able to see those numbers yet, there we go. Our A squared, well, A is the side that's opposite our angle, because our angle is A, so that'll be the square root of 5 squared. But again, you know what, because I'm going to find cosine, I'm going to go ahead and solve this formula for the inverse cosine, just to get this all in at once and make it perfect. So A squared minus B squared minus C squared over negative 2BC. So the inverse cosine of the square root of 5 squared minus the square root of 10 squared minus the square root of 13 squared all over negative 2 times the square root of 10 times the square root of 13. Now, some of this pretty obviously you could just do in your noggin, so you don't have to be punching all these nasty radicals in here. Because the square root of 5 squared is 5, the square root of 10 squared is 10, and the square root of 13 squared is 13. So 5 minus 10 is negative 5. Negative 5 minus 13 will actually give us a negative 18. And just to make it a little easier to punch in, you might want to go ahead and multiply those two radicals down there and punch her all in at one time. So let's see what we've got. We are going to need negative 18 divided by parentheses negative 2 times second square root of 1/3. And that is the cosine of our angle. So now we need second inverse cosine of our answer. And there it is, 37.875 degrees. And that was measure of angle CAB. So a lot of cosines there to get that one working.